Welcome to The Explainer. Today, we're talking about something really cool, the secret sauce behind Node.js's amazing performance. Yep, we're diving deep into the event loop. We're going to break down exactly how it works and why it's such a game changer for building modern apps. All right, so let's just jump right in with a huge question, one that every developer has to think about. This isn't just some textbook problem, right? This is the reality for pretty much every service you use every day. And you know what? Node.js has a really, really clever answer to it. So the secret here, it's a completely different way of thinking about the problem. You see, traditional servers, they're kind of like a single checkout line at the grocery store. One person at a time, you're stuck waiting for the person in front to finish up. It's totally blocking. But Node.js, it's more like a great waiter at a busy restaurant. They take everyone's order, send them all to the kitchen, and then the kitchen works on everything at once. This whole non-blocking idea, that's the key to everything. Okay, so let's pull back the curtain a little bit and actually meet the maestro that's conducting this whole orchestra. We're going into the engine room. This is where all the magic really happens. So what is the event loop, really? Well, at its heart, it's exactly what it sounds like, a loop. It's this process that's just running and running and running, constantly checking a list of things to do. Think back to that waiter. They're not just standing around, right? They're always circling, checking on tables, seeing which food is ready from the kitchen. They never get stuck in one spot. The loop just keeps moving, keeps processing things as soon as they're ready to go. Now, this loop isn't just some chaotic mess. No way. It's actually a super organized cycle with very specific phases. First up, it handles timers. Things like set timeout. Then, it checks for any I/O stuff that finished up from the last time around. The poll phase is a big one. That's where it grabs new events, like network requests. After that, it runs callbacks you've scheduled with set immediate. And finally, it handles any close events, like a socket closing down, before it starts the whole cycle over again. This structure is exactly how Node juggles so many different things at once without getting confused. Okay, that's cool, but what's the point? How does all this technical stuff actually help us in the real world? Why do so many developers love this asynchronous way of doing things? Well, it's simple. The payoff is absolutely huge. And this is why Node.js has just exploded in popularity. I mean, you get this massive performance boost because your server isn't just sitting around waiting for things. It can handle thousands and thousands of connections at the same time. That makes it perfect for things like chat apps, online games, or live stock tickers, anything that needs real-time data. And the cherry on top? You write your code once, and it just works, whether you're on Windows, Linux, or a Mac. Super convenient. Now, hold on. If you've ever dabbled in front-end web dev, you've probably heard about the event loop in the browser. And you might be thinking, oh, I know this already. But it's super important to understand that they are not the same thing. They might share a name, but they're built for completely different worlds and totally different jobs. See, the event loop in your browser, its whole world revolves around you, the user. It's listening for your clicks, your typing, things like that. But the Node.js event loop, it couldn't care less about clicks. It's all about server-side work. We're talking about handling network requests, reading and writing files, what we call I/O. This means Node gets access to all these powerful built-in tools for file systems and HTTP servers, stuff a browser could only dream of. And, like we'll see in a bit, it has a secret weapon. It can use background threads for the really heavy lifting. All right, enough with the theory. Let's get down to the practical stuff, because working with the event loop is amazing, but it also means you have to watch out for a few common traps. So let's walk through the big ones so you know how to keep your loop healthy and your app running like a dream. Okay, pitfall number 1. This is the big one. The cardinal sin of Node.js development. Do not block the loop. Seriously, if you run some long, heavy calculation right on the main thread, everything else just stops. Dead. No new users can connect, no other work gets done, your entire application just freezes. So the big takeaway here is you can never, ever let one single task hog that main thread. You've got to offload the heavy work. Either you make it asynchronous so it can run in the background without stopping everything, or for those really intense number-crunching tasks, use something called a worker thread, which basically runs it on a completely separate track. All right, next up is a more subtle one. You know how in Node you're always listening for different events to happen? Well, what happens if you attach, say, hundreds of listeners to the same event? Every time that event happens, your app has to go and tell every single one of those listeners. That's a lot of overhead, and it can really start to slow things down. So the key here is just being smart and proactive. You can actually tell Node to set a limit on how many listeners can be attached, which is a great way to catch potential problems while you're developing. Or you can use specialized libraries that are built from the ground up to handle tons of listeners really efficiently. Okay, this next one, it's like leaving a ticking time bomb in your code. Because Node is asynchronous, an error might not pop up right away. But trust me, if an error happens inside one of those callbacks and you haven't prepared for it, it's just a matter of time before it blows up and crashes your entire application. This one's not a suggestion, it's a rule. You have to wrap your async code in error handling, always. Whether you're using a classic try-catch block with async await or chaining a .catch onto a promise, you have to plan for things to go wrong. It's the only way to build a stable, reliable application. Ah, yes, callback hell. If you've been around Node for a while, you probably just shuddered a little. This is that dreaded pyramid of doom you see in older code, where you have a function inside another function. It's just a nightmare to read, a nightmare to debug, and an even bigger nightmare to try and change later. But thankfully, we have a way out. Modern JavaScript has given us these amazing tools to escape the pyramid. I'm talking about promises, and especially the beautiful async/await syntax. It lets you write asynchronous code that looks, well, normal. It's clean, it's easy to follow, and it's a total game changer for writing maintainable code. Our final pitfall is a real silent killer for servers, the memory leak. This is what happens when your app keeps creating things. Maybe it's data in a cache, or maybe it's those event listeners we talked about, but it never cleans them up. So slowly but surely, your app uses more and more and more memory until finally it runs out and crashes. So for this one, you really have to put on your detective hat. You can't just wait for it to happen. You have to be proactive. Luckily, Node gives you the tools you need. It has built-in profilers that let you take a snapshot of your app's memory, so you can see exactly what's taking up space, hunt down those leaks, and fix them before they can cause any real damage. Okay, so we've been through a lot. Let's bring it all home and tackle one of the biggest, most common points of confusion about Node.js. And that question gets right to the very heart of everything we've been talking about, the secret to its performance. And the answer isn't a simple yes or no. It's a little more interesting than that. And here it is, the final takeaway. Node.js isn't really single-threaded. Not exactly. See, your JavaScript code, the code you write, and the event loop itself, that all runs on a single meme thread. And that's why you can't block it. But, and this is the magic part, behind the scenes, when it comes to the heavy lifting of I/O, like talking to a database or reading a file, Node.js hands that work off to a whole team of background threads. So you get the best of both worlds, the simplicity of writing code for a single thread, but with the massive power of multi-threaded I/O working for you under the hood. That is its superpower. So the only real question left is, what are you going to build with it?